Hi, how are you? Good afternoon to all. This is Guillermo from STT, and I'm speaking from San Sebastian inside the lab we have in our headquarters. And this afternoon, we will show you how the EDDO works. As you probably know, STT is a software development company. We develop motion capture and analysis solutions for different users and for different purposes, research, clinical purposes, sport analysis, and different disciplines. And this afternoon, we will show you what is the EDDO and how it works. First of all, I would like to say that EDDO is the portable solution for optical mock-up system. We have cameras in the ceiling in case we have a still lab where the people is coming to perform biomechanical studies, or in case we need to move and go to our customer's house or to our gym or to a different placement, we offer this solution. It's a very small solution. It's a 3-camera unit inside one and unique device. And with just one cable and a tripod, we can capture quite large volume in real time. These cameras can go up to 120 frames per second, and we can capture different exercise of movement. In the webinar we are doing today, we will show you the setup, so how the setup looks like. We will show you an example for gait analysis on treadmill. That's why we have a treadmill behind me. Then we will perform, for example, individual joint analysis. We can do an elbow, a shoulder, a wrist, a knee, an ankle. We will perform a test for the wrist analysis. And at the end, we will finish with lateral bike fitting. So with just this unit and a bike and a trainer, we will perform a lateral bike fitting. At the end of these samples, we will leave a couple of minutes in order to answer all your questions and all your worries about how this works or about any other question we can answer. So thank you to all and hope you enjoy this webinar. Let's start. Okay. I will start sharing my screen as well. Here on the laptop, I have installed the EDDO software. So you will be able to see together the scene right away from this camera and as well as the desktop. Let me start sharing in a second. Okay. Normally, you should be looking at this software called EDDO Biomechanics, and I will launch here the different windows, and I will use the software as we normally use, and as probably you potentially could use. First of all, what we will need to do is the setup of the scene and of the space. We don't have very big requirements, okay? Because this is a portable solution, we don't need much more space than maybe 2 or 3 meters between the subject and the camera unit. Apart from that, the unique important thing is not to have direct sunlight coming through the windows, okay? As you know, this is a optical device, it has itself 3 high frame rate infrared cameras, and they do have a LED infrared light. That's why we need to have blinds or stores in the windows. Apart from that, there are no more requirements. All you need to do is calibrate and start working. How the calibration works? Let's do it. If I open this in the software configuration ribbon, we have the calibration with 3 points. This is a small tool as you can see here in my hand, this is the calibration 1, and we will perform the calibration within maybe 1 minute or less. All we need to do is to move the one around the area where the subject is going to be moving, okay? It doesn't make sense to move the calibration or the one around this area if the analysis is going to happen around here, okay? So it's important to move around where the movement and where the markers will be once our subject or user is performing the movement. I am pressing it once. This launches this one. Let me do this a little bit smaller. Sorry. I am canceling, okay? I want you to see the cameras in a better way. Okay, so we can see the 3 cameras all together, and if I go back to calibrate, I will start moving the calibration 1 around the area, as I said, for a couple of seconds. So all that I need to do is imagine where the walker or the runner is going to be and move the one around there. Okay? More than enough. Now I can press OK, and the system is performing the internal calculus. Once it finishes, it says the system is calibrated and the calibration quality is good. So, great. Now, next step. We need to set where the floor is. I have set the space, but we don't know, and the system doesn't know where is the floor. To do that, we need to place just 3 markers in a one shape. So drawing kind of a 1 number with a little bit of an imagination. This is a 1 over the ground. I am pressing OK. And now I have set up the floor. Great. We can start capturing. Let's go that. This is the live mode. So we can imagine that someone is going to be here walking over the treadmill. So I need to remove the markers from the ground. I will put them on my pocket. And now I will ask a colleague of mine, Alberto, to come in order to have this setup ready to start walking. As you can see here, Alberto is wearing some markers in different places. Depending on the model that we are using, the marker shape is going to be different. In this case, we are performing, let me press a new capture. Let's set Gait running analysis with EDDO, it's correct. The biomechanical model is called Helen Hayes. We are doing the capture in real time, and we will perform 30 seconds of capture. We can set a couple of minutes, 10 minutes, or just some seconds. In this case, because this is a webinar and we want to do different exercises, let's set 30 seconds for each test. I need to set some parameters about the weight or the distances or lower limb anthropometry. But once all this is filled, then I can start placing the markers. This is the marker set. This is the Helen Hayes EDDO marker set. So I need to place 15 markers in this anatomical position. There is a drawing helping us to place the markers, but also each marker has a defined anatomical position. For example, the number 5 is the lateral epicondyle of the right femur. In order to save time, I have already placed them on Alberto, and we can start doing. Can you start walking, for example, at 3 kilometers per hour, please? Okay, so now Alberto is going to be walking on the treadmill without starting the capture, okay? Just to get used to the treadmill, and whenever I want, I can go back to the software, and I can press OK, preparing the execution, as you can see here. Now it's loading the 3D scene, 2D views, plot windows, different screens. And once everything is ready, 1 second. Okay. Okay, probably this is the demo effect. It always happens. No worries. Exactly, it's a demo effect. I will relaunch the EDDO software. Meanwhile, Alberto is gonna continue warming. Let me try to kill the process, okay, and launch again. These are some samples I did before. Okay, EDDO is loading again. I will need to set the user, then the marker set, and then start the capture. It's gonna be quite fast. So, step one, I'm gonna select the user. I'm selecting, in this case, this, Guillermo on the database. I am performing a new capture. I am selecting EDDO, okay. All this is correct. I am pressing OK. Now the system is connecting with the cameras, is launching all the screens, and now is ready to start. I can tell Alberto that I will start, or I can just press the button without noticing Alberto that I will perform the analysis. Okay, as you can see now, this bar is in green, the time starts moving, and we are getting information in real time from Alberto. Okay, so we can see this movement, we can see the knee angles in real time or any other parameter. Hip angles, pelvic angles, ankle angles, velocity, leg stiffness, different parameters. I can stay here for those 30 seconds, and once the capture is done, okay, Alberto, you can press stop. I can have a look to the software to see, okay, let's see what has happened. Let's see what the system has recorded. We can see here different cycles between the second 0 and second 30, and some parameters on the right in a numerical view. This numerical view is quite easy to understand. We have 3 columns for each side. The left side is drawn in red, the right side is drawn in blue, and we have the minimum value, current value, and maximum value. So if I move the cursor or I play it back, I can see the numbers, how they start moving. This is a total 3D scene, okay? Even that we have record from behind, and because all the markers are visible from behind, I can rotate the scene, I can zoom in, I can focus at any angle or at any position of this gait analysis. Once I stop and I finish doing the capture, something quite interesting is to go and analyze the cycles. The cycles were automatically detected. Here, we can see all the cycles detected in these 30 seconds. I am removing the ones that are not interesting for me by just double-clicking on the toe off event. And here I can see all the cycles, one above the other, between 0% and 100% of the gait cycle. I can focus on the hip, on the knee, or on the ankle. With this done, I can just press this green button on the top of the software, report button, and this generates a report very, very fast. I am pressing it once, and now in less than 1 minute, the software will activate and will go for the template and will fill all the parameters with the information from Alberto's biomechanical analysis. With those 30 seconds of capture, we are giving you, or we are plotting maybe 6 or 7 page long report, very focused on the gait analysis. Let's wait a little bit. This computer is not super powerful, but with a little bit of patience, it will work. It's generating the report. It launches a word processor, a text processor, and let's see. 1 second. Okay, and here it is. So, the name is Guillermo, demo laptop, EDDO Systems, birthday, and today date. Okay, the capture was done today, and the reporting was generated today. We have selected 12 left strides and 15 right strides. the cadence was 96 steps per minute at 3 kilometers per hour on the treadmill. So we are here, we can see the first page of the report with right stem phases, times, percentage into the gait cycle, and some parameters about the gait analysis. Then we are doing the analysis on the pelvis, you can see versus the three planes, pelvic tilt, pelvic obliquity, pelvic rotation, and same on the hips, left and right, on the knees, left and right, and the ankles. At the end, you get like a summary of plots and a summary of angle versus angular velocity. Something quite interesting on these plots is that, for example, if we are focusing on the ankle, on the knee, sorry, let me zoom in a little bit. Here we can see this is the left and right knees. We can see the average value drawn in light red and light blue for the left and the right knee, but behind we have like a gray shape of the knee. That motion is the normative data, okay? So out of a very big database we generate some years ago, we have the normative data for gait analysis. And you can have a look to it and you can see how equal or how different the Alberto shape is to the normative data. I don't know the reason to that, but someone, known people about gait biomechanics could answer why the right knee is moving different from the left knee. Left knee is quite on the same shape of the normative data, but the right one has less flexor extension on the beginning of the cycle, mainly because of I don't know why. Whatever. So this is what we can do with the EDDO and gait analysis studies, something super fast, super easy to understand, and it's straightforward. So once I press this button, this capture is going to be saved. I can relabel it as Alberto test webinar at 3 kilometers per hour. And we are done. Okay. Step one from the webinar is done. Let's move into the test two. So what we are doing now is we will remove all the markers from the lower limb from Alberto, and we will place the markers, for example, on the left arm in order to perform wrist analysis. Let's do quite fast. Okay, Alberto is removing the markers. Meanwhile, I am pressing new capture. I am selecting, instead of the gait or running analysis on the EDDO, I will look for example, the wrist. Here we have wrist, left wrist or right wrist. Let's select the left one, and because I can't remember very well where are the markers placed, I can press this button on the top right in order to launch a PDF that explains us. Okay, this is the ERGO left wrist biomechanical model, and with just 4 markers, we can perform this analysis. So let's do that. I am selecting this one. Let's place kind of a small table here on the scene. We can remove, we can remove this one. Can you take off the cable, please? Okay, so all we need to do is to put this like this. We are doing the left wrist analysis, so you need to move the wrist like this. You need to place like this, okay? It's the left one. So we are doing this movement at the beginning and then this one. I will put this a little bit lower. Yes, can you put like this? You need to be comfortable, okay. So we need to move. Okay, up and down, and then left and right. Perfect. We will do that. I will place 4 markers. I'm gonna show a little bit closer to the camera. So we are performing this movement. Up and down, so flexion extension of the wrist, and this movement, lateral ulnar movement. Marker placement, okay? So we can see number 1 on the left trocheter, number 2, number 3, and number 4. It's gonna be quite easy. 1, 2, 3, and 4. 4 markers. Thank you, Alberto. Let's go back to the software. Let's select, instead of 30 seconds, let's say, for example, 20 seconds. It's quite a short analysis. I am pressing OK. Now the software is loading this left wrist biomechanical analysis. And as soon as I press start, I will ask Alberto to start doing those exercises. So as we said at the beginning, move up and down, left wrist, and then left, right. I will tell you when to move between one another, okay? Okay, can you start moving up and down, please? Okay, perfect. We can see here the angles. Okay, and now can you start moving left and right? Up to the maximum. Very well, very well. 2 more, 2 more. Okay, thank you, Alberto. So the capture is done. We don't need to do anything else. In less than 2 minutes, we have done the setup, the capture, and here we have all the numbers and all the analysis. This is the, well, let me show you in a bigger way so we can resize all this. So these are the flexor extension drawn in green and the radio-ulnar deviation. So this movement drawn in red from the left wrist in this case. Without doing anything else, I can just press this button on the top as we did with the Gait analysis. And this will generate a very simple report with all the information that we captured just 1 second ago. So here it is. In this case, it's a 1-page report, and we get maximum flexion, minimum flexion or extension, mean standard deviation, absolute limit, coefficient of variation, and range of motion. And same with the wrist radial ulnar deviation. So it's a very, very simple report. It's a very simple analysis, but it's very powerful, very fast, and very easy to use. Thank you, Alberto. Now let's go to the third test, okay? Let's go to the third one. Let's move. We have here a small bike with the help of Urko and Alberto. We are moving into the room, into the scene. I am closing this. Let's go back to the software. I can save this capture. For example, Alberto left wrist webinar test. Let's save it. It's saved. Now I can go to the live view in order to see what cameras are looking at. I need to be sure that the scene, I am doing this a little bit bigger, okay? But I need to be sure that the cameras can see where the bike is, okay? Otherwise, I should move the cameras in order to be focusing where the bike is. This is where the bike is, and here, so it's gonna be fine. We have a space above, around the rider. So can you please go into the bike? I will place it, no worries. Let's remove, okay. We have here a saddle pressure mapping technology. We are compatible with different devices. I didn't tell you, but we can integrate third-party devices in the software. Not only information coming from the cameras, so the movement, we can integrate force plates, pressure mapping technology, heart rate sensor, surface electromyography, high speed video cameras, all those devices can be integrated and synchronized into the same software. So I am removing this saddle pressure, thank you, and we will do the typical analysis, just the motion. Okay, you almost know the marker set, but I need to double check. So I am doing exactly the same procedure. I am selecting the user, in this case is Guillermo, because it's already selected. Now I am pressing new capture once, and on the biomechanical model list, I need to look for something about bike feeding. I can filter, but here we can see, starting with the B, bike feeding left side and floor, correct. We are on the left side, so let's select that one. We are doing the analysis in real time. We can perform the analysis, for example, for 45 seconds. We need to set the crank length. These cranks, I know them, they are 172.5 millimeters. Tibial tuberosity, I need to measure it, so I am taking a measuring tape in order to measure this tibial tuberosity in order to be super accurate. I'll be right back, 1 second. Okay, can you put the crank at 90 degrees? Okay. So at 90 degrees, I need to measure this crank, this tibial tuberosity. In this case, is 10 centimeters, so 100 millimeters. It's fine. Practice level is not important at this time. And what is super important is the marker set. So I am pressing again this button in order to double check that I have set everything fine. So bike feeding left side, I need 8 markers on the body plus 3 on the floor. So let's double check. Alberto has it. Okay, the arm is correct. The foot, let's have a look. Okay, it's one missing here. The greater trochanter is also missing, and we need to set those 3 on the floor. I have some on the pocket, so let's set the 3 on the floor. It's defined here how to place them. So above the bike, on the left of the bike at 90 degrees, and another one behind the bike. And then this missing 2, I will show you them super closely for you. Greater trochanter, can you put the crank down? Okay. And we need a small vertebra. We need to put as well at 90 degrees below the left ankle, so around there. This one should be aligned with the pedal axis, okay? Let me move a little bit. I am moving very little forward. Okay, great. Can you start pedaling, please? So, as we did, in the same way that we did with the Gait analysis, we should capture once the rider or the walker or the runner is used to the movement. Okay, can you start a little bit faster? Okay, so I can go back to the software. We already set those 45 seconds of capture. I am pressing OK. Now the system is preparing the execution, connecting with the cameras, and I am starting now. Okay, now it's a good example. We are getting all this in red. Probably something is missing. Okay, I know what has happened, but it's a good example. Okay, there is no information. The system cannot track where the markers are. We don't know. I need to stop the capture and do one thing again. What has happened is that there are some markers below the floor. Why below the floor? Because we have set the floor on the treadmill. Do you remember that? So we set the floor probably around 10 or 15 centimeters above the real floor. And that's why now those 3 markers, they are under the floor. What is something that is not allowed into the software. So we need to reset the floor. Can you take down from the from the bike? I need to reset. So I need to grab again a one shape. Can you imagine this one? That one, it's gonna reset the floor. I am doing it quite easy with just this button. So it's asking, are you resetting the floor? Yes, I'm resetting it. Okay, operation complete successfully. So now the real floor is the floor that we need. Okay, and now we can ask Alberto to go back into the bike. Can you go again on the bike, please? Okay. Marker. Can you start pedaling, please? Okay. Perfect. So now we can repeat the process. New capture, set, press OK. Okay, and we are starting. Can you change the? Are you pedaling correctly or have you changed into the other direction? More. Yes. More. Upper. Go with this one. Upper. And now this is like that. Okay, don't touch the changes, please. And continue pedaling. Okay, and now I'm pressing start. Okay, and there it is. So now we have Alberto pedaling on the bike in 3D, in real time. So if Alberto stops for a second, can you stop for a second? You can see how it stopped. Can you continue again? So here we have all the cranks, all the angles, all the cadence, knee angles, whatever Alberto is doing, we are tracking it in real time. Let's continue for another 15 seconds. I am moving this in order to see the numerical view in light mode. So we are getting all the information from the left side. 3, 2, 1. Okay, thank you, Alberto. The capture is done. So now the software is refreshing all those 45 seconds of capture where we can see what Alberto did. Let's wait a little bit. It's refreshing. It's saving the capture. I can go to the cadence. We can see the cadence. He was pedaling around 60 RPM at the beginning. Then I asked him to stop pedaling, and then he starts pedaling again. So I can set, for example, the time between the second 20 and the second 40. Analysis limit event. I can set a limit event there. Another one on the second 40, for example. Analysis limit event. And I'm gonna generate a report only for those times. So that is the region of interest that I want to have on the final report. And same with the numerics and all the information and all the biomechanical calculations. I am pressing the report once. This is a road bike, correct? And similar with the other examples. In just a couple of seconds, we will have a lateral bike fitting report from Alberto performed in a small study, in a small lab, in just a couple of seconds. So here it is. Bike fitting, road discipline, performed today, recording time 45 seconds, average cadence, some parameters about the bike. And here we have knee flexion, knee extension, and total range of movement from the knee. This is the knee front trajectory, what is quite vertical. So that means Alberto has a very good shape or a very good knee moving while he's pedaling. Then we have some other parameters. I am not bike fitter, but those parameters are interesting for bike fitters also to help Alberto in this case to improve his performance or to prevent injuries or prevent pains in their back or their wrist or knees, whatever. So it's done. It's done. Nothing more is left. I am closing this. I am saving the capture. In this case, autosave now. I want to relabel as bike fitting lateral Alberto webinar test. I can say, okay, the size was correct, the adjustments were poor, cycling was quite cool. Notes, this is an example. I'm saving it. And that's it. Just to explain you, okay, EDDO is capable of different things, not only what we have seen. We have seen the gait analysis, wrist and the bike fitting, but we can perform also this big list I am sharing with you right now. I am opening a new capture. So EDDO is able to perform left ankle or right ankle analysis, lateral bike fitting as we did. We can check the calibration. We can study the dorsal spine. We can study the elbows. We can do the gait and running analysis. We did the gait and we could do as well the running analysis. We can study how the hip is moving, the knees, lumbar analysis. We can perform as well road bike measurements quite fast, in less than 5 seconds. We can measure the main frame distances. We can study the shoulder rotation analysis, shoulder and elbow analysis, vertical jump, and also the left and right wrist. Thank you to all for this time and for this for joining us today in this webinar. I will go back to the platform where the webinar is doing in order to start reading your questions in case you have any. Thank you. I will stop sharing the screen in a second. Okay. Okay. Okay, there are some questions. I am opening. Okay, I am opening the questions dialog and I will start reading some. Okay, could this, I will start from the very beginning, okay? So, Bria Lewis is asking, okay, could this be used for other disciplines? Yes, we can use this device for other disciplines. Can we use it for golf? No, we can't. But no, we can't because a very important limitation, okay? Markers must be visible, okay? You can imagine myself wearing, with a golf club on my hands, and if I'm doing a rotation on a golf swing, the markers behind or on the other side of my body won't be visible, okay? Because I am not transparent and because these cameras cannot look through my body. So if I rotate, in any rotation movement, I am losing the marker's visibility, and that means that I cannot perform those analyses. So only lateral captures can be done. That's why, for example, when I'm doing a shoulder analysis, if I am laterally showing the markers to the camera, I can do this analysis or this analysis or different analysis, right? But if I am rotating, then I am losing the marker's visibility and I won't be able to perform those analyses. Let's answer the next one. Can this be used for general movement, a screen like overhead squat, single leg squat, and other movement screening? Yes, we can do, as I said, CMJ movement, but as I said, from lateral, okay? So in case we want to have both legs simultaneously, we should do from behind, and we should place the markers in positions where the EDDO unit can see the markers every time. Okay, let's go to the next question. Okay, it's refreshing, I don't know why. Okay, can we use the EDDO Biomechanics saddle pressure technology together with this device? We can use it, the saddle pressure from EDDO Biomechanics, but it is not synchronized with our software, okay? For the moment, we have only integrated the one from Biomechanics. This is something out of our possibilities because EDDO Biomechanics are very shy with their information and they don't want to share with any third-party software. That is not the case from Biomechanics that we are doing from years ago. Okay, we have a problem with internet connection. I think I'm back. Let me continue reading some questions. Okay, can you do triathlon bike measurement? Okay, it's a very good question. For the moment, the only model that we have integrated into this EDDO bike measurement is the road bike measurements. As you know, the triathlon bike measurements are a little bit different from the road bike, and we need to place markers in some places, probably inside where the forearm holders are. So as long as the markers are visible to the system, we could do that. But for the moment, we didn't develop yet the bike measurements for triathlon bikes. So for the moment, only for road bikes. We are in those direction and trying to solve those issues and launch new possibilities, triathlon bikes, mountain bikes, and gravel bikes as well. Okay, is there any limit of duration of the capture? Is asking Ashley. No, the duration can be between 1 second and half an hour. What is the limit? The RAM memory in the computer, okay? We cannot manage more than, I think it's, I'm not telling because I'm not sure, but we cannot manage infinite amount of memory. So that's why there is a limitation, but between 1 second and 20 minutes, the capture is safe. Okay. Okay, Rafael is asking, Rafael, it seems very similar to retool system, but once you have record, there is a reference range on how to position the cyclist. Okay, we are independent from brands, okay? We are not pretending to teach you and to tell you if you need to move the saddle up, down, forward, backward, or if the pedals or the cleats are correct or not. That's your job. That's the bike fitter's job. And we don't pretend to recommend or advise anyone what to do. As I said, we are independent from brands. We are doing this recording at 120 frames per second. And yes, the solution is quite similar to what Retool is doing, but we are using another technology. These are not linear cameras. These are passive markers, instead the active ones from Retool. And we are giving the metrics that the bike fitter community is asking us for, okay? And we are independent from brands. Yeah, this is something quite interesting and quite important. Okay. So EDDO is the complete system. I don't know what you mean, Alia, with if EDDO is the complete system. EDDO is this camera unit, one power cable, dangle, the software, markers, and the calibration tool. And that's the complete system. You don't need more than that in order to perform for the test that we have done today. So you can perform gait analysis, running analysis, lateral bike fitting, individual joints, with the limitation of visibility, okay? You cannot rotate, you cannot put markers behind the EDDO or in the other side of the EDDO. That's the limitation, but it is a complete system. Okay, price, very good question. The price for this system with the software, permanent software, okay? The license is permanent, there are no annual fees, and you get the software for you forever, and you don't need to pay any more as long as you don't want to update. If you want to update, you can pay a small fee for those updates, but that fee is optional. The price for this is between 9,800 and 14,000. Okay, this price depends, of course, on the models and packets that you ask for. It's not the same if you are focusing only on bike feeding or on gait analysis or on other disciplines. So, in case you want a formal quotation and an accurate price, please email us. You can email to sales@EDDO-systems.com, and we will answer you and give you a formal quotation. Okay. Okay, how we sell the system? Okay, we have different channels for selling this. You can email us, phone us, give us a call, or you can contact our local distributors in different countries. We have a big net of distributors all around the world. But as I said, maybe the fastest way is if you email us, we will answer you with the quotation or the contact in your country or near you. Okay. It's quite strange to look for questions here. Let me go down. Okay, Jason is asking, although it would not be as fluid as the 4-camera 3D EMA, can't? It's refreshing. Sorry. Can 2 cameras be connected to do both left and side simultaneously? Okay, it's a super good question. The answer is no, it's not possible. In any case, it will be more expensive to have 2 EDDO units than one 3D EMA with 4 camera setup. But the answer is no, we cannot connect 2 EDDO units simultaneously. Okay, Aliak, what is the after-sales service? Okay, we have a permanent support team answering your questions over email. You have 1 year of priority support. That means that we can teach you in a remote call, over TeamViewer or remote support to teach you and to solve all your questions. Okay. Very good question, Will. Asking if is there the raw data available? Yes, I didn't explain during the webinar because there are many features on the software that maybe we should do another one explaining all the buttons, how it works, and what can you do with the software. But yes, we get all the raw data from the motion and we can export into different formats in order you to study by yourself or to print it out or to connect to any other MATLAB or motion capture software. So we can export all the trajectories and all the X, Y, and Z position of each marker on each frames. And we can do very easily. It's just right click and export. Let me look for more questions. Okay, when will you start to support the Biomice? As soon as the Biomice start sharing or they have a API or SDK to share with third-party software. So this is something, it's not on our roof, it's on the Biomice roof. As I said, Velometric is a very good quality saddle pressure. You don't need to remove and change the technology inside the saddle every 2 years, something what is happening today with the Biomechanics because it's another completely different technology. So the sensitive surface lasts forever. You don't need to change it. So I recommend you try and test the biometric saddle pressure. Okay, let me look for other questions. Miguel Duque is asking, we saw how it measured the wrist ankles in simple movement, but if, for example, the person should do circles with the wrist, will the software measure both ankles in those cases? Yes, the answer is yes. The movement is free. I mean, you can measure whatever you want to do, clap your hands or do any kind of movement. But because the report is focusing on how the motion of flexor extension and ulnar deviation ratios are, the report is pre-programmed like that. I asked Alberto to perform exactly those exercises. But if you don't want to focus on those movements and you want to perform the analysis in any other way, you can do it, of course. The thing is that the report that we are generating will not answer exactly what you did. Rafaelo, Damian, Miguel Duque. Sorry, because every time someone is reading, I am losing the line. Jason, okay, Jason, I have already answered this one. Alexander, okay, how can you fix marker better if runner starts? Okay, yeah, it's a very good question. There are different technologies in order to place markers, okay? We have the typical Velcro base, but you know, if someone starts running, maybe the Velcro falls down. We can use Tenso spray. It's a glue spray prepared for the skin, so it's safe for the screen. We can use that spray. We can use as well, I can show you, this is the Tenso spray. You can glue over the skin, yes. Another possibility is to use, let me 1 second. We can use these snap button markers. Let me show you. So these are the electrocardiogram bases. They are very cheap and you can attach directly on the skin. They have like a gel. So you can attach on the skin. They attach perfectly well. And then this marker has, instead of a Velcro base, a snap button base, okay? So with this one, you can attach there and the movement is safe and it doesn't fall down if you are sweating, okay? So there are 3 possibilities. Typical Velcro base plus adding kinesio tape, for example. Then Tenso spray, it's also helpful. And the snap button bases, the bases from electrocardiograms, you can use exactly the same with these snap button base markers. So all these 3 possibilities are there. Okay, Alia is asking very deep questions. I will try to answer the short ones, okay? Otherwise, I won't have time enough. Okay, Jason is asking, will be there an Eisen bike protocol coming in the future? Okay, Eisen is another technology we are using to capture motion. Those are inertial sensors. Maybe I can show you one. We did a webinar some months ago about how Eisen is working. But for the moment, we don't have, and there is not plan to have Eisen-based solution for bike fitting. Mainly because bike fitting needs very accurate distances, okay? Not only angle, but distances and measurements. And Eisen is not able, not ours, any other inertial sensor solution is not accurate when doing measurements, mainly because they don't calculate translations, only rotations. Okay. Let me look for any other question. We have some minutes left. Post-analysis, yes. Okay, I think I'm done. Thank you for your time. Thank you for you all to joining us this afternoon, this super rainy afternoon here in San Sebastian. We had some internet cuts because of the storm and some hack attacks, but hopefully the session went well. And as I said, thank you for this afternoon. If you have questions, please email us to sales@sdd-systems.com or info@sdd-systems.com. Follow us in our social medias as Instagram, YouTube, and different channels. And thank you for all. Bye-bye.